Manufacturing operations can be broken down into 4 general processes: job shop, batch processing, assembly line, and continuous process. This product process matrix graphic shows the relationship between these 4 processes and the 3 main variables of each: product variety, equipment flexibility, and production volume. The first factor is product variety, or how much the product changes from customer to customer. A steel manufacturer, for example, will normally produce a single product. A tool shop, on the other hand, produces each product based on the unique and specific needs of each customer. The second determining factor is the type of equipment used to produce the product. The steel manufacturer has very rigid, highly integrated equipment needs, and each piece of equipment has a specific job that rarely changes. In the case of a tool shop, the project dictates what equipment will be required. The third factor that can determine how a product is made is the volume of product to be produced. A steel plant, for example, produces in huge volumes. A tool shop, on the other hand, will produce a comparatively small volume of custom tools, depending on customer needs. By using these 3 factors, we can divide the various manufacturing processes into 4 main groups using this product process matrix graphic. The 4 types are job shop, batch process, assembly line, and continuous process. When a highly specialized product is needed in very low volumes, usually on a customer order basis, the process generally used is called a job shop. A good example of this is a tool and die shop. In the tool and die shop, precision metalworkers manufacture durable, customized tools that are used to stamp out parts, forge steel, or act as a mold for liquefied metal or plastic. The equipment can produce a wide variety of parts in very low volumes. In this example, a special stamping tool is required to produce engine gaskets. The tool designer receives the specifications from the customer and designs the part on computer-aided design or CAD equipment. The CAD equipment allows the operator to quickly design an almost endless variety of products in a very short period of time. From here, the machine shop begins to grind the metal into the required dimensions. Holes are drilled and tapped, and the pieces are locked in place. This one-of-a-kind tool is now ready to be tested, and sample parts are stamped out using the new tool. Precise testing and measuring equipment ensures that the specifications have been met. In each step of this process, the equipment used could also be used on a wide variety of other machine tools. Because every project is custom-made, the equipment must be flexible enough to change with each new job. But since producing a large volume of product isn't necessary, the process can be geared toward providing an exact custom product. When a higher volume of specialized products are needed and the product designs are more standardized, a batch manufacturing process is normally used. This kind of process uses a disconnected production line flow. In other words, batch products are normally produced in small lots or batches. The production of Caterpillar equipment is such a process. Caterpillar produces 4 families of construction and agricultural equipment, but all in relatively low volumes. Their plant in Aurora, Illinois, uses flexible equipment to produce 24 different models of wheel loaders, compactors, excavators, and agricultural tractors, all in the same facility. Specifications for each vehicle vary, so most equipment must be adjustable for multiple tasks. For example, this machining center produces 58 different parts for Caterpillar drivetrains. A variety of products produced at relatively low volume with flexible equipment are what characterize a batch manufacturing process. When a small variety of highly standardized products need to be produced in large volumes, an assembly line process is required. This process, originated by Henry Ford in 1913, typically utilizes a connected line flow production that moves the product along, generally on a conveyor system, past a series of workstations. At each station, parts are brought to the line to be added or assembled until the product is finished. An obvious example of an assembly line process can be found at the Ford assembly plant in Atlanta, Georgia, where Ford Tauruses are assembled. The assembly line method allows a relatively large volume of cars to be produced. The process, however, is very structured so that each line produces only one model. An assembly line designed to produce a Ford Taurus cannot easily switch production to a Mustang. Yet, there is enough flexibility at each workstation to offer a variety of options on the model being produced. When a very standardized product is needed in very large volumes, a continuous process is the best type of manufacturing to use. At this Nucor steel plant in Crawfordsville, Indiana, which produces 1 million tons of steel annually, the product is produced continuously. In fact, this plant was designed for the specific purpose of producing a large volume of standardized goods in the most cost-effective manner possible. Since the end product is very standardized, each piece of equipment performs a specific function and is rarely, if ever, modified for special needs. This roll housing, for example, weighs 130 metric tons and is welded into position. And this ladle, which holds the liquid steel before it's poured into the mold, has a capacity of 112 metric tons. As the name continuous process implies, there is little need to stop production during the manufacturing process. In fact, while the plant is rolling thin slabs of steel at one end of the plant, more liquid steel is being prepared for casting at the other end. The result is a manufacturing process that uses very rigid equipment to produce a large volume of a single product.